inverse trigonometric functions. So basically we have trigonometric functions, we are going to find the inverse of them. So if you see from the 11th grade, right, or I can go to the 10th standard also, basically you know that trigonometric ratios in the first place. Let's forget about functions. Trigonometry is basically applicable for right angle triangles, right? So when you take the right angle triangles, what is trigonometric ratio going to speak about? It speaks about the relation between the angles and the sides. So it gives you the ratio. That is why you called it as trigonometric ratios in your 10th grade. The same concept when it came to the 11th grade, you replaced theta with x. That's what you did. You didn't do anything else. Theta was replaced with x, right? Because you started treating the trigonometric ratios not as just numbers, you started looking at them like functions, right? So when you go back to your 10th standard, you would have learned only the ratios of some special angles like 0, 30, 60, 45, 90. That's why it was easy. But here what is happening, the complication has increased because you are seeing for all the angles that are possible. And second difficulty that would have arisen is, there you saw everything in terms of degrees, here the concept of radians came into picture, right? So once you understand those basics, it will be easy. Because in this chapter, we need to write everything in terms of radians. I hope you're able to see. Nowhere it is written in terms of degree, right? So I'm assuming that you people got clarity of what is domain, codomain, and range. Are able to visualize by looking at a function, whatever function let it be. But at least you will be able to define what is the domain and codomain. At least you can try it, right? Okay. So till now, what we saw is most of them were algebraic functions. The previous chapter we never touched trigonometric functions. Now we are going to get into the concept of trigonometric functions, and most importantly, we are trying to find the inverse of it, right? So you need to have the basics in your mind. Having said this, the first trigonometric ratio that you know is sine. Then you have cosine. Cosine is basically the complementary of sine. Why do we call it as complementary? Because you know this, right? You have sine theta, cos theta is going to be sine of 90 minus theta, right? Similarly, you have tan and you have cotan or cot, right? Then you have secant and then you have cosecant, right? This you can remember it like they are the complementary, right? So if you take this sine theta for instance, right? So what did I say? Theta is replaced with x. That is the only difference. Now let's forget about this domain and range as of now. If I give you a question like y is equal to sine x, and I ask you to plot this on a graph sheet, what will you do in the first place? For you to plot something on a graph sheet, it's very simple. You have x-axis and the y-axis. So graph is a two-dimensional shape. It's a rectangle. You have grids. You need the coordinates of the points which are there on this curve. As simple as that. So when I look at it, what is the first value by default we will substitute, even without thinking? You will think of 0. Right? When you substitute a 0, let me look at it like f of x also. They both mean the same. So when I put x is equal to 0, what is the function value coming out to be? F of 0 is called as function value because it is the exact value at that point. What is it coming out as? 0. And as I told you, the only difference is instead of angles in terms of degrees, you'll be substituting in terms of radians. That is the only difference. So you need to be careful with this. Next, if I substitute x is equal to 30, instead of me saying 30 degrees, what would be the value in terms of radian? How did he get that in the first place? 180 by 180 by 6 means you should by 30, no? Multiply by pi. Why is it so? How did he get that in the first place? You are correct only. Tell. 60. 60 is a very big number. Huh? Can you try it? Can you frame it better? You're almost there. Try it now, you'll be more confident. You're almost there. It's very simple, Mike. I explain the concept of circle. All these are called as circular functions also because you're dealing with a circle. See, if at all you have memorized, no, for your understanding, I'm trying to tell you, listen to this. I'll give you a compass, okay? You keep the sharp end fixed. You have the pencil which is rotated, right? What is the meaning of rotation? You're actually making some angle with respect to a line. Can I say? Whenever I use the word rotation, you're trying to cover some angle. Now, if I rotate the compass through one complete revolution, right? If I rotate the compass through, ignore the shape of the circle. If I take the circle's radius to be r, how many degrees am I supposed to rotate it? 360 degrees if I rotate, what is the equivalent length I am able to cover? I am able to cover a length of 2 pi r. If I take theta degrees, then let me say the length that I am covering is L, right? Then if I cross multiply, one book is going to cost 10 rupees, two books will cost. Just unitary method, cross multiply and solve. It is going to be 360 into L is equal to 2 pi r into theta, right? So what is that you are going to get? So what is radiance definition in the first place? You can take the circle to be of unit radius, for instance. If I take this value, it is going to be 1, right? So what will this L by theta be equal to? It is going to be 2 pi by 360. This 2 pi and this will get cancelled. It will be 180. So that's why you got it as pi by 180. That's why you need to keep multiplying with that value. So this kind of a circle whose value is 1 unit is called as a unit circle. So basically you take a unit circle, when you rotate the compass to 360 degrees, the equivalent distance you are covering is in terms of, instead of 2 pi r, you can write it as 2 pi, so that you can create a relation between degree and radian. That is why we say 360 degrees equivalent to 2 pi radian. Okay. So the advantage with radian is you can speak without the help of a protractor, you will be able to define the angles. That is the reason why we take radian into consideration. Okay. Now, if I take this x is equal to pi by 3, for instance, what is going to be the value of f of pi by 3? F of pi by 3 is sine pi by 3. So I directly went to 60 degree. It is going to be root 3 by 2. So suppose I have x is equal to pi by 6, which is 30 degrees. What is f of pi by 3? X is equal to pi by 4. How much is pi by 4? 1 by root 2. Now I take all these values and plot it on a graph sheet between 0 to 90 degree. I am only looking at the first quadrant. So between 0 to 90, if I take the values, what will be the value I will take here? I will take pi by 6, I will take pi by 4, I will take pi by 3, and 90 is how much? Pi by 2. So at pi by 6, what is the value I am getting? Pi by 6, I am getting 1 by 2. After that, pi by 4, I am getting 1 by root 2. Then at pi by 3, I am getting root 3 by 2. And at pi by 2, I am getting 1. After that, what will happen? It will start decreasing. But the question is, are these the 4 dots that are there, or the values will exist intermediate also? It will be there, no? So it is a kind of continuous function like this. So when you plot it on the graph sheet, it is going to look something like this. It's going to look like a wave like this. So it will keep going. Right? I'll show you all these graphs. Right? If I look at this as a function now, my job is to define the domain and the range for it. What is domain? The set of all x values that it can take, which gives you a finite value of y. So if you look at this function, what is the highest value you are getting? Highest value you are getting is 1, and the least value you are getting is minus 1. But you will not get, there is no value for this function where when you substitute it, it is going to lead you to infinity. So I can substitute any value of x which ranges from minus infinity to plus infinity. That is the reason why the domain of sin x is R. But what is going to be the range of it? Minus 1 to 1. Minus 1 to 1. This is the maximum value, this is the least value. So it is minus 1 to 1 closed interval. Meaning you are able to generate minus 1 and you are able to generate plus 1 also. Where will you generate plus 1? Pi by 2. Then where else will you find? So how much is this value? So how much is this value? This is pi 180 degree. After that, pi plus pi by 2 is 3 pi by 2. So you have 3 pi by 2. At 3 pi by 2 you are finding minus 1. Then again it keeps going. For that you need to know the trigonometric equation. I am not getting into that. Okay, that's a very big equation. I am not touching that. As of now, you would have understood at pi by 2, 5 pi by 2, 7 pi by 2, you are going to get the values of this sort. Am I clear with this? Right. Now, what about cosine function? It is going to look something similar, right? But the difference is going to be, it will start from 1, it will keep going like this. So don't copy anything now, just concentrate. I'll show you the graphs later. Right, it keeps working like this. Am I right? So what is going to be the domain of this function? Minus infinity to plus infinity, which is again real numbers. And what is going to be the range? So this is minus 1, this is 1. Minus 1 to 1 is going to be the range. So range means you need to look at the y-axis. Next. What about tan? So we'll have this. I'll show you the graphs. So if you see, this is how the graph for sin x is going to look like. Right. So tell me, what is the domain? We already know. Domain is going to be real numbers. So how can you write it? You will write it as r or minus infinity to plus infinity open bracket. And what is going to be the range? Closed interval minus 1 to 1. I hope this is registered. Right. The next sheet will have the inverse of it, about which we'll discuss later. Similarly, this is the graph for cos x. Right. I hope you understood how these graphs have actually come by taking all the values. When you plot the values, you're going to get a shape like this. Things you need to remember are, where is it touching 0? And where is it touching minus 1? And where is it coming to plus 1? These are all the points you need to mark on the graph sheet. Okay. So here, what is going to be the domain? Again, it's a set of real numbers. And what is going to be the range? Minus 1 to 1. Right. So this is the graph for tan x. So for tan x, how is the graph looking like? If you see the previous two graphs, they were continuous. There was no break. Whereas here, what is happening? There is a break at which point? So logic is very simple. You will not be able to plot anything on the graph sheet where the y value is tending to infinity. Where is tan tending to infinity? At odd multiples of pi by 2. Right, that is pi by 2, 3 pi by 2, 5 pi by 2. Similarly, on the left hand side also, minus pi by 2, minus 3 pi by 2, minus. It will lead to infinity. That is where, if you observe the graph at that point, there will be a break. But here we will not put a circle. There is a break. We put the line like this. The meaning of it is, when you learn the same concept in terms of limits and derivatives or continuity and differentiability, we are trying to say this 3 pi, for example, let me take pi by 2. On the left of pi by 2, the function is leading to plus infinity. On the right of pi by 2, it is leading to minus infinity. Am I clear with this? Are you able to understand? So, if you look at this, how are you going to define the domain for this? The domain is very simple. You can substitute any real number. Look at the x-axis. For every real number that is aligned along the x-axis, it is working, except the points where you have the odd multiples of pi by 2. So you have pi by 2. How do you write the odd multiple of something? You will write it as 2n plus 1 into pi by 2, where n belongs to integer set. Am I clear with this? Now what about the range? So look at the y-axis. What is the least value you are getting along y-axis? Minus infinity. And what is the maximum value you are getting? Plus infinity. You can never achieve these values. That is why you have an open interval. Or how do you write it? You write it as a real number. Am I clear with this? Is it clear, guys? Right. So in a similar way, we have three other functions. What are they? Cosecant, secant, and cot. Yeah. If you look at cosecant, y is equal to, you have cosecant x. So y is actually 1 by sin x. I told you one thing. What is it? From the domain, you need to remove the value of x, which is generating an infinity. When will this function give you infinity? Sai Kalyan, concentrate. So when I put 0 here, what will I get? 1 by sine 0 is 0. So I get an infinity. Except that, is there any other value that will give you infinity? Is it only 0? It is 0, pi, 2 pi, 3 pi, like this. Similarly on the negative values also. So how are they? Pi, 2 pi, 3 pi. So pi is constant. What is the multiplication factor? They are n pi. Okay. So the domain says, what does the domain state? R except n times pi, where n belongs to z. What about the range? It's not real numbers. Observe. What is the least value you are able to observe? Whenever the graph is not touching, right? Touching the y-axis means it is going to infinity or minus infinity. What is the least value it is going to? Minus infinity. It's open interval. To, first of all, observe minus infinity. Where is it stopping? To minus 1. Minus 1 is coming or not? Close it. Union. Where is it again starting? There is a break between minus 1 to 1. 1. So if you observe, basically, this is the reciprocal of sign. Means whatever was the range of sign, right? You exactly need to write the reverse values of it. What was the range of sign? It could take the values between minus 1 to 1. Where is the value cosecant being taken? It is taking all the values except between minus 1 to 1. Why is it so? Because it is the reciprocal, not the inverse. This is what many people think. Inverse and reciprocal are not same. Are you able to understand? So is this point clear? Right. So after this, I'll give you the consolidated data, then you can copy it. What about this? What about the domain? Domain is, see, why is it? It's very simple, okay? If you have anything apart from sine or cos was registered in your mind. Tan onwards, what you can do is start writing it as sin x by cos x. Where will tan lead you to infinity? Wherever cos x is leading you to 0. Denominator, if it becomes 0, y value will be infinity. Where will cos lead you to infinity? Sorry, 0. At odd multiples of pi by 2. That is the reason why from the real number set we removed all the odd multiples of pi by 2. Similarly, for cosecant x, what is there in the denominator? Cosecant x, the previous case, 1 by sin x. So sin, where is it leading you to 0? 0, pi, 2 pi, like that. So eliminate all those from which set? The real number set. Okay. Then in this case, y is equal to secant x. So y is equal to 1 by cos x. So since cos x is coming in the denominator, this will have a similar domain to whom? Which other function has cos? Which other function has cos? Tan. So whatever is the domain for tan will be the same domain here. So it will be all real numbers except n belongs to z. What about the range? Look at the graph. Look at this. Come from minus infinity to minus 1 union. Am I clear with this? So how will you look at it? Because it is 1 by cos x, whatever values cos x is generating as range, you need to eliminate those values and write the remaining values. Okay. And what is the last function left out? So cot, if you see, it will exactly be in the reverse as that of tan. Tan is going like this, no. This kind of function is called as increasing function. Increasing in the sense when you move to the right, it is increasing. Again, when you go in this direction, it is increasing. Whereas cot will exactly be in the reverse. What will happen? When you move in the positive direction of x-axis, the value of y will decrease. Okay. So remember these terms. As of now, you need not worry about. Look at the graph. Tell me. So y is equal to cot x. So cot x is cos x divided by sin x. So where is Is there a possibility where sin x can generate 0? Yes, where? 0, pi, 2 pi, all those things, right? So, what will the domain be? You can substitute any real number except the place where the sin x is generating a 0. Means what should I remove? So, this is similar to which other domain? So, what will have sin x in the denominator? Cosecant, right? So, this and cosecant have this similar domain. So, where n belongs to z. What about the range? Kalpagesh, can you tell me? Can you tell me? Look at the graph, try, even if it is wrong, I don't mind. What is going to be the range? Where is the value of graph going in the downward direction? Where will this touch? Infinity, correct them, but what is the sign you need to add? Minus. And where is this graph going in the upward direction? Positive. So minus infinity to infinity is also called as real number. Am I clear with this? So having all this data consolidated, that is what is given in the first sheet. So now I hope you are able to find the relation between them. Cotangent and cosecant, why they have the same domain. Similarly, tangent and secant, why do they have the same domain? Now is the logic clear? Right? So it will take some time, don't be under pressure. It will take some time. Maybe within the next week you will be able to solve problems based on this. Chapter is very simple. I have to teach the theory, and now I'm going this deep. Problems are very simple in this, and in this also you have only first exercise. Second, again they have removed. I don't know why.